Hear that before? Anybody heard that statement? I think it's a terrible thing to hear. It's an awful thing to say. Developers don't know jack about security. That was actually a famous line from a security conference several years ago. Developers don't know jack about security. Well, there was a security guy sitting in the audience then, and his response was, well, I got news for you, friend. You don't know jack about development. And this is part of the friction that we have, and we still have, between the security field, the security people, and the developers. And we don't speak their language, or they don't speak our language. And this just creates friction, and we're not getting the results that we need. And this is creating a situation where we're creating insecure software because we're not working together. So I'm going to tell you up front what I'm going to be talking about. No surprises. This is the bottom line. Threat modeling is great. I'm going to tell you all about threat modeling. Anybody know what here have done threat modeling? Know what threat modeling is? I'll explain what I mean by threat modeling and what it is and why it's so great. But the problem is that we can't be the ones doing it. It's not security people that should be doing threat modeling. Statistics came out last year that for every 100 developers, you know how many security people there are? On average. So that's a whole lot of security being built, sorry, a lot of software being built without any security going into it. There's not enough of security people to go around. So we need to get the developers to be doing the security for us. We need to get the developers to be doing threat modeling and not just the security people. And if we want developers to be doing threat modeling and security in general, it needs to be quick. Can't take up all their whole time because they're busy. It needs to be lightweight. We can't give them heavy process. It needs to be agile because this is the way they work. And the way to do this is by focusing on business value. I'm going to show you how I mean. Because if we keep trying to enforce our heavy security process and doing everything the way we've always been doing, we're going to be looking like this guy, trying to do the same security things and not changing, adapting to the different context, the different situation. So let me introduce myself. That's what I'm going to be talking about. My name is Douglen. All right, there's my contact details. You'll see my Tigger face bouncing around the internet, especially on Twitter. And the most important thing you should know about me is that if you ever want to buy me a drink, I like my whiskey smoky, I like my beer stout, I like my coffee strong. I do have 5 kids at home, so these drinks are kind of important. The other things you might want to know about me is I have a boutique consulting company called Bounce Security. We do software security consulting, things like threat modeling, research, and other things. I am one of the leaders of the OWASP Israel chapter. We just had a great global AppSec conference in Tel Aviv. We have a yearly conference called AppSec Israel. It'll be next summer, 2020. If you can make it over to Tel Aviv, that'd be great. I'm also one of the moderators on the Security Stack Exchange site. Anybody here know what that is? Anybody have a profile? It's kind of like exactly like Stack Overflow, questions and answers, but for security, by security people, about security. I spent some time mentoring high school kids about cyber and getting into the field and whatnot. I'm also the founder and one of the leaders of the OWASP Threat Model Project. I'll tell what that is in a moment. So if you don't know what threat modeling is, in a nutshell, security analysis of your software. Basically, it's a structure for this analysis. It gives you a framework to start thinking about threats, about attackers, about what can go wrong, about what security we need to build into the system, what we need to fix, and why. And we do this by reviewing the different components of the system and finding the different security flaws that are potentially in that component. And then once we understand these threats, we have a better understanding of how they work. We know better how to fix them. We understand the risk involved, and we know what it takes to fix them. So generally speaking, threat modeling is usually done by some kind of diagram focusing on data flows, how it comes into the system, where it goes, who has access to what data, where the data comes from, finding the attack surface, the collection of entry points, highlighting the different assets that we're trying to protect, focusing on those, calling out the scary trust boundaries, which gives us the attack surface. And we usually use some things like DFDs, data flow diagrams, to follow those data flows. But a lot of people use other types of diagrams, things like swim lanes and process diagrams, whatever they are, as long as it's something visual that you can trace the data through the system. So overall, it's a 4-step process for threat modeling. There's a pre-step of first defining what goes into your model, what part of the system you're working on right now, you're modeling. And then the first real step of the threat model process is to decompose the application, to break out the diagram, the DFD, and so on, whatever diagrams they are, the different parts, the different components. Step 2 would be to find the threats, the attackers. It's kind of important to know what you're fixing, but also to understand the threats and find the involved risk level. And there's whole methodologies around that. The third step is probably the most important. It's defining the countermeasures, what we're going to do to change our system design. Because a threat model is not just about threats, it's about, the whole purpose is to have secure software. So that's the step 3, defining the countermeasures. And then step 4, like any work we've done, did we do, we need to analyze it, remodel our threat model, is it complete, and so on. If you're not familiar with what a DFD looks like, if this is the first time you're seeing it, you have over here, you have your central process, that could be a service, API, whatever it is, and you have your databases, you have your data flows going in, data coming out, and then over there you have the user, of course, sending in the withdrawal request and identification and so on, and that comes in, and that crosses the scary trust boundary. That's why it's flagged in red, and that's what we're going to start with, obviously, because that's part of our attack surface. That's our entry point. So that's a very simple data flow diagram. Now, there are a lot of different approaches to do threat modeling. Those 4+1 steps that I mentioned, there's a lot of different approaches. There's STRIDE. I'm going to go into this in detail. It's an acronym. I'll explain what that means in a moment. STRIDE by element. There's attack trees, and there's focusing on the assets that you're trying to protect, and software-centric, breaking down the components, and trying to get into the head of the attacker, attacker-focused, and a nice risk-based threat modeling approach, we'll explain in a moment. So I mentioned STRIDE. STRIDE is an acronym. That's spoofing, pretending to be somebody you're not. Tampering, changing data you shouldn't have access to. Repudiation, claiming you didn't do something that you did. For example, telling the bank, I didn't authorize that transfer. It wasn't me. Now get my money back. Information disclosure is reading data that you shouldn't have access to. Denial of service, preventing other users from having access that they should have access to. And elevation of privilege is basically doing anything that you shouldn't. And we take these categories as basically categorization of all the different possible attacks that an attacker might want to do, or the attacker goals. And we apply this one by one to each element in our diagram. For example, we could go and apply STRIDE to the web server, and we say, are there spoofing attacks here? Can I pretend to be a different user? Okay? But also in the other direction, can I spoof the web server? Can I pretend to other users that on the web server and steal passwords and so on and so forth? Obviously, if there's HTTPS, then not, but then we ask that. Tampering, can I change data en route? Right? I look at the data flow. It's HTTPS, I can't tamper with it, but there might be other attacks on the web server or the application server. And in this way, I go through one by one each category on each element. But then I could also go and look at the back-end elements. For example, the flow between the application server and the back-end messaging bus, sending in, let's say, some message queue, and I'm sending in different messages on JMS, and now we can ask these STRIDE questions all over again, each element. Can I spoof the messaging bus? So I intercept every message sent by the application server and comes to me. Or the other way around, can I pretend I'm the application server and send my own messages into the bus? Can I tamper with the messages that are already there, or the messages being sent if this protocol isn't encrypted? Can I read the messages from there, right? Can I erase that? And in this way, I go through each element and ask you these questions, looking for threats in each of these categories of goals. Now, it doesn't need to be a DFD. It could be a process diagram. Some people use swim lanes. Whatever kind of visual diagram works for your team, for your system, that makes sense. And you can go ahead and do that. Another very interesting tool is called attack trees. Attack trees is very good for fleshing out a lot of different details for a specific set of threats. For example, I have a specific threat that an attacker may be able to read other users' secret messages. And then I have here a whole bunch of different vectors to get to that goal. Now, I might be able to read the messages because it's stored in the browser cache, unencrypted. Or I may be able to bypass authorization. Or there's SQL injection, okay? And there's a lot of different vectors to get to that one goal. And each one of these needs to be mitigated. And that's what we have down here, the green leaves. For example, in order to prevent the browser from caching these secret messages, I'm going to implement the anti-caching headers, right? I'm going to enforce authorization checks, and that prevents this vector. SQL injection we know how to prevent. But then I have over here yet another vector. User may not have logged off a shared computer, so the next person at the kiosk can just go and read that user's messages, and there is no defensive mechanism here. There's no countermeasure. So it's very easy using this attack tree to find the unmitigated threats. It's also really good for a pen tester or for QA to come in and say, okay, we don't need to start checking this. We need to verify that this is implemented correctly. There's no point in checking this because we know it's not mitigated. Until the developers go and create that security control, I'm not going to waste time testing that. Another approach I mentioned is called risk-based methodology. And the poster child for this is called PASTA. Probably all hungry for dinner already. PASTA stands for Process for Attack Simulation and Threat Analysis. Okay? It's a very rigorous model. It's called risk-based because it comes from the risk management field. And those 4 steps, it breaks it down into a lot more detail, and there's 7 steps here. And it involves things like threat intel and business analysis and a whole lot of other stuff, and becomes a very rigorous threat model. And the output of this is, without a doubt, one of the best threat models you're going to get. Because when you're working on something, you know without a doubt these are the right risks to be working on. Because you have all the statistical detail. You have all that data to back you up. And you know when you fix these threats, these are the right threats to be fixing in the right possible way. Now, these are great tools, PASTA especially, but also the other methodologies. These are great tools for security officers. The security department loves this, right? Any kind of CISO is going to love this. It's fantastic for a chief risk officer of a multinational bank. You know what it's not so good for? Not so great for the way the developers work, right? That big 7-stage process with statistical data does not really fit in with the concept of continuous integration, continuous deployment, and so on and so forth. So anytime we go to do threat modeling with developers and try to get them to integrate their process, there's going to be a bunch of pushback. And let's look at some of the comments that I've gotten over time, and everybody that does threat modeling with developers say, yeah, I've heard that all the time. So these are some of the issues that come up with trying to do threat modeling with developers. Right? You could send your application off to the security department, and they come back 3 weeks later, or you call an expensive consultant, they'll come back after 2 months with a really big threat model with a PASTA and so on and so forth. But we're doing 2-week sprints. We don't have time to wait for you to come back after you finish with your massive threat model. It's got to be faster than that. Security is everybody's job. We like saying that, right? Security people love saying security is everybody's job. Everybody needs to be doing security. But you know what? I'm a developer. What's my job? I write code. I need to deliver features. These features need to bring in customers. They need to sell more product. That's my job. Sure, it's my responsibility, security. I need to take care of security, and also performance, and also usability, and also a ton of other things. Right? Security is not my job. My job is development. I already have 8 bosses now. 8 bosses, Bob. Do we security people really want to be boss number 9? Doesn't work. Think like an attacker is particularly insidious because it sounds really good, right? Think like an attacker. Think about everything that the attacker could possibly want to do to you and stop that, except we think like developers. We don't think like an attacker. If we thought like an attacker, we'd go be a pen tester, right? But we think like a developer. And more than that, think like an attacker has no real valuable guidance here. It doesn't tell you anything of what I need to do to prevent the attacker. How do I think like an attacker? What does that even mean? Adam Shostak, who literally wrote the book on threat modeling, he's the father of modern threat modeling, likes to say, everybody, think like a chef. Does that mean you can now make fantastic soup? Does that mean you can bake like Mario Batali? There's no guidance. It doesn't really help anything. And then you say, well, why bother threat modeling? What they want to do is take over the world. They want to steal money from our account. There's no point in threat modeling. What value am I getting out of threat modeling? Because we know what they want to do. Now, overall, the threat modeling, we're talking about these big processes and diagrams, and it's kind of waterfall-y-ish, right? Because we have these big design, and we take all the use cases, and this is the way threat modeling people like to work. Security professionals like to do that, especially consultants like getting all these big design documents and the use cases that are very detailed, except that developers don't really do that anymore. Use cases don't exist. They have very lightweight, minimal user stories. As a user, I want to whatever because that's it. And then that gets fleshed out as they develop. It's an invitation to a conversation to find out additional information of what they need to develop. So there are no use cases, and trying to build a threat model based on these use cases doesn't necessarily work. And in the same manner, a lot of agile proponents like to say no big design up front. Well, if you don't have a big design up front, you can't build a big model up front, in which case you're going to get stuck in a hole and not know how to get out of that. One good thing that threat modeling does do is create a whole lot of security documentation. You can trace back the threats, you can trace back why we built this feature to this countermeasure against that threat, except that when I read the functional design, I don't have that information anymore. I have my big threat model over there, I have my design over here in Jira or Confluence, whatever I'm working on, and never shall the twain ever meet. And in the same manner, part of that is because that what happens is that I change the design in Confluence, but the threat model hasn't been updated. So that's how things get out of sync, and it's no longer relevant. Another thing that threat models like to produce is huge, long list of threats. And of course, for each threat, you have your bunch of countermeasures that this is what we need to implement, this is what we need to fill. And you get this massive Excel sheet. Ever seen a developer develop their features based on an Excel with hundreds or thousands of lines of threats? If it's not in my backlog, I'm not going to touch it. If it's not in Jira, I don't even know about it. So what am I going to do with this massive Excel sheet with thousands of lines? And one really good thing about threat modeling is that you don't waste time building controls that you don't need. You don't build unnecessary security. But you do waste time threat modeling unrealistic things. Developers are stallions, right? They love to run forward. They love to build things, 2-week integrations, continuous integration, continuous deployment, 2-week sprints, everything just really running fast. Security people, we like to tear things apart. That's kind of a mismatch. It doesn't really work well together. Every quarter, security person drops in and says, hey, how you doing? Tell me what's been going on. What you been doing the past 3 months? 3 months? I don't know what I did 3 days ago. That's what we have stand-up for. 2-week sprints. I'm not going to deal with every quarter the security person drops in and wants me to hit reset and start all over. And this happens far too often in big corporates. And to be fair, part of this is because, again, 100 developers, 1 security person, we simply can't scale. We like to pretend we have these automated scripts all over the place, but when it comes to things like threat modeling and secure design, there's simply not enough of us to go around. And what happens as a result of that, the developer is like, I will take your advice into consideration. Thank you very much. Let's meet for lunch sometime. Sounds good. And goodbye. And that's about where it ends, because it's not usable very often. And as security people, we're stuck with the shovels in our hand trying to paddle upstream. We're using the wrong tool for the job. It's not getting the job done. We're spending so much effort and not getting where we need to go at the speed that we should be going. So let's try a different approach. Threat modeling is still a great thing. Still needs to be done. However, it needs to be done differently. So let's review what threat modeling is at its core. Adam Shostak, the father of threat modeling, says whatever methodology you're using, it basically comes down to answering these 4 questions. Number 1, what are you building? What are you working on? This is the system you're building, right? The DFD, the diagrams, the actual software design, the code. What are you building? Number 2, what can go wrong? These are the actual threats. These are the attacks. These are the things, the security bugs you might be building into your system. Number 3, what are we going to do about it? That's the countermeasures, right? This is the security controls that we're going to build, and this is effectively the point of the whole exercise, to get secure software. And number 4, did we do a good job? Does our model, our DFD, actually reflect the code that you're actually building? Did we capture all the user stories? Did we find all the threats? Did we mitigate all the high threats? Did we fully mitigate them? Maybe we put in a mitigation that leaves residual risk, okay? And did we introduce any new threats based on the new countermeasure that we built? For example, the common example is that on a login script, a login screen, you might be worried about brute forcing attacks. So let's put in a lockout mechanism. After 5 wrong passwords, we're going to lock you out. And what did we just do? We introduced a denial of service threat. So we need to review the countermeasures that we built to make sure that, yes, okay, we need to make sure that that account gets unlocked after a certain number of time. Now, Adam likes to quote George Box, and I like to misquote Adam. All threat models are wrong, some are useful. Okay, if there's one thing you take away from my talk, it should be this. Okay, all threat models are wrong, some are useful. Now, all the other models that we've been trying to build, whether it's Stride or Pasta, whatever it is, tries to make the threat model as correct as possible, right? Pasta gives a really, really almost 100% correct model. Except all threat models are wrong. They can't be right. But some are useful. So if we accept that the threat model is wrong, I say grab it with both hands, lean into being wrong, be proud of being wrong, but be useful. Optimize for usefulness. In this case, what I mean by usefulness is secure features. Let's find, as quickly as possible, the security features and the functionality that we need to build without worrying about the other 80% of the model. Let us be wrong as long as we're useful. So, I'm proposing a different set of questions. Okay? Number 1, why are we building it? Okay? Why are we building this? Why did we choose to implement this user story right now? Why are we building this feature instead of that other feature over there? Usually it, produces more money, more users, whatever it is. Now, take into account developers know exactly what they're building. So coming in and say, build a threat model and start with what are you building? They know what they're building. Start with why. Okay, what is the goal? What are we trying to achieve here? And how does the system actually get whatever value we're trying to get out of this feature? What is the correct flow? What is the happy path to get that value? To squeeze as much value as possible out of that feature. And what do we, as system implementers, as the developers, what do we need to do to ensure we stay on that happy path? What do we need to do to ensure that we get that value out of this feature? Now, if you've noticed, it's very similar, and there's no 4th step, by the way, because did we do a good job? That's already built into the Agile workflow. There's the retrospective that they always have after you build anything. So you're already doing the did we do a good job, and you don't need to rehash that separately from the development. Now, if you notice, this is very similar overall to the original 4 questions, and it's just pivoted around a very simple concept. It's pivoted around a small idea, which I'll warn you, can be shocking. It is offensive to some security people. Okay, so the concept that it's pivoted around, developers are optimistic by nature. They build things. Leave your FUD at home. We don't need that. Leave your stuff behind. People are building stuff here. The sky is falling. Of course everything's broken. Have you seen the internet? We know that. It doesn't matter. We're still building new features. So instead of focusing all the time on attackers and this will break and that threat and what will go wrong, Let's focus on what will go right. Let's focus on how to keep things going right and not worry about every possible thing that could go wrong. A while back, I noticed an argument on Twitter in the context of airline safety. And in airline safety, they don't talk about preventing accidents or making sure it doesn't crash or basically stopping hacks and attackers, right? They worry about safe transportation, secure features, not how to prevent that kind of attack or stop that threat, how to provide secure features, value. That's why I call it value-driven. And the way to do this is get developers working with us. We have a huge workforce of 100 times larger than the security people. Jim Manico likes to say every software engineer is now a security engineer, whether they know it or not. They're either doing a good job or they're not. So if we get them on our team, then we can do it. There's simply not enough security people to provide all the software security we need to do. So we need to get developers to do security for us. And we need to give them the right incentives and the right workflow to work it with us. So what does that workflow look like? Number one, we need to focus. We need to focus on what is important. Let's skip the things that we already know about. We don't need to bother threat modeling SQL injection. All right? We don't need to wait for the security team to come back after 3 weeks and say, oh, if you have a website, you have a massive threat, you need to deal with cross-site scripting. We know that. We don't need the consultant to spend 2 months to say, oh, you better put TLS on that endpoint. Yeah, that's kind of well known. That should be the point that we start from and threat model after that. Now, there is an assumption here, but I'm making me very explicit about that assumption, that our developers know the basics. Okay? They have basic code hygiene, right? Input validation, and so on. They know that basic stuff. And if they don't, well, that's where training comes in. And if they do, you still need more training. Fine. Train your developers, train your QA, give them the basics, and then have threat modeling start where that leaves off. And don't waste time on the obvious things. The other thing that's very useful to short-circuit those basic things is what's called a threat library or threat patterns. For example, if you have a relational database, there might be SQL injection, right? If you have a web page that you output data, cross-site scripting is a thing. So why bother modeling it? You can automatically pull out the threats and the countermeasures. I'm using Docker. I don't need to start researching every possible hack that there might be. If you're using Docker, use these guidelines, and so on. And you know, I'd like to say that there's a huge open source library around that. There's not yet. It's starting to be developed. OWASP has the Cloud Security Project and the Threat Modeling Project. There's a few commercial tools out there, and I've worked with a lot of companies that are creating that internally for their own specific threats, their own specific systems. And that's great. But the point is that's kind of a shortcut to the baseline, because threat modeling should be above the baseline. So that's number one. We're focusing on the unknown. We're focusing on the actual business logic attacks. Number two, we need to focus on the scope. We're not going to do the whole system all at once. We're not going to do all the architecture over and over again. We're going to do for each user story, or the epic, or the feature. Every team works slightly differently in Agile, so wherever you're doing your minimal design, your just-in-time design, wherever you're doing that, you're doing this threat model. Basically, what I'm saying is, when you're doing your just-in-time design, design includes a minimal threat model. Whether it's your discovery or the sprint planning, that's when we're doing this threat modeling. Okay? They talk about just enough design. I want us to talk about just enough threat model. Minimally viable threat model. Okay? And the threat model becomes part of the user story. It's not stored in Excel. It's not stored in my security documentation. It is part of the feature documentation. It's built into the user story. Now, for each user story, or epic or feature, we want to find the actual value. Usually, you're going to follow the money. That's usually the value. We want to sell more product. We want to upgrade users. We want to get more eyeballs on my social network for cats. Whatever it is, we want to create more value for the organization. You're building this feature, usually some form of money. Sometimes You want to know how people die, whether it's airline safety or hospitals or government systems. Sometimes how people die might be meeting regulations. Whatever that value is, that's what you need to find. You put that into the user story, the actual goal, the why. And the way the workflow is that for each user story, we're explicit about the goals. Again, they usually know the goals. Sometimes it's implicit, sometimes they don't know it. But if the product owner defines the actual goal of this user story, developers can now align around that. And that now becomes our incentive. When we build our user story, it needs to provide that value. So we're no longer talking about the security of the feature or the possible attacks. We're talking about how to ensure that value. And usually user stories describe the flow, the happy path. Sometimes it's not completely explicit. Very often they skip the failure states. So we're going to be explicit in the user story and describe what happens when I can't log in, what happens when the values I provide are wrong, what happens when I ask to transfer more money out of my account than I should be allowed to. And one of the important things here is to find assumptions. One of my mentors used to say that the attacker starts with your assumptions. Whatever the developer assumptions are, that's what the attacker will find. He was talking about in the context of penetration testing, but it still lasts. Now, the tricky thing is that finding your own assumption is usually very hard. You're locked into your own bias bubble. You're not going to know about it. It helps to have a discussion with other people, and you can find each other's assumptions. There's a whole bunch of methods and techniques to find your own assumptions, like Socratic questioning. That's a whole nother separate psychology talk. But once we find the assumptions, once we're explicit about our assumptions, we can validate them. It's either true or it's not true, right? Or we can enforce conditions in code by putting it into part of the design. You put it into the user story, the developer now goes and puts checks in code to verify that that is actually the case. And you no longer have those implicit assumptions. And you need to be, again, explicit about what happens when things go wrong. When you fall off the happy path, what happens then? So that's basically the whole flow overall. I'm going to go into more detail in a moment. I want to give you a quick little example of what I mean by finding the value and how this contributes to a threat model. So I'm going to use the OWASP Juice Shop. Anybody that's familiar with it is basically the best place not to buy juice on the internet. It's an example of a modern web application that has all these broken vulnerabilities built into the system. So it's used for practice and pen testing and so on. So this is a great site, very similar to many other e-commerce sites. You go and you choose your juice, and we're going to choose the banana juice because I have a gorilla at home that needs to be fed. And this is about as much architecture as we need. You have your single-page application built on Angular. You have your Node.js server calling it a SQLite. That's about as much architecture as we need for this point. Now I want to highlight one little feature. When you go to checkout, before you check out, you can press this little orange button, which is a gift coupon, and there's a link there to their Twitter, and you can get a coupon code to get 30% off, right? If you use it within the date, before the end of July. And I put the coupon code here, and it applies 30% off, and I get it. Great. Now let me ask you this. Why do I have that feature? Why did we decide to build that feature? Anybody? Cheaper juice, right? No, cheaper juice is not the reason we built the feature. The reason we built the feature, it's marketing, right? Marketing department came out with some study that during National Juice Week, if we give a 30% discount, we'll get 40% one-time customers, and half of those will come back, right? We'll get 10, maybe 15% uptick in continual customers that will keep buying our juice at the full price. So what is the value of this feature? What is the point of it? What's the goal? More customers that come back, not for this sale, that will come back and buy on the full price. Okay, great. So let me ask you this. If that's the case, yeah, sure, we could go and try and fuzz that coupon and see if we could change it, but let's ask, based on that value, how can I subvert that value now? Sure, I could ask, okay, instead of 30%, everybody's going to say, well, could I make it 60% by changing the code? Can I make it 90%? Can I make it 200%? But now let's invert that value. What happens if I block that coupon code from other users? Now nobody can use the code. What happens if when anybody uses the code, we'll now get a 30% increase in price or double the price? What happened now? Fine, it's a higher price, big deal, we get more money, right? No, wrong. Those customers are never coming back to you because you just ruined their experience. And the whole point of this feature is new residual customers. You want them to come back. And you just screwed them over by doubling their price. Small change in concept, but it's a lot easier for developers to grok and be able to deal with that type of concept because that's what they're dealing with. They're implementing business value. So it's easier for them to do. Now I'm going to show you a few techniques that you can provide for your developers and let them use this to wrap this into their process. Some of these will not apply to every team, so take what you like from this list of techniques, see what works, try different things. Some things will work, some things won't. Number one, definition of done. Definition of done is something that Agile teams use already anyway. It's the process that the team agrees on. They will not start developing unless there's acceptance tests explicitly designed. They will not accept it until all acceptance tests have been tested. Okay? Acceptance requirements, unit tests, whatever it is, this is the process that they require before it moves on to the next phase in the process. So we could put in our own security process, assuming the team agrees to it, of course, and we'll say, don't start developing this user story unless you have a minimal threat model built into the user story. And security tests, whatever we decide, whatever we agree on, this will now be part of the process. And that's it, you're in. This is part of the process now. This is the way developers work because, well, that's the way they agreed to work. And that is already enforced by their own processing. You don't need to chase them anymore. Acceptance criteria, again, is something that they already have. They have the functional requirements. The acceptance criteria is a testable statement of how do I know that this requirement has been met. I can add that in for security requirements now. So for the login screen, when I log in with the wrong password, I should be locked out after five wrong attempts. This is now built into the user story. Now they need to implement this. And it's testable. And because it's testable, I can define that I need to build security unit tests. And the QA will build those tests and run those tests and verify that this is always the case. For example, the QA team will now test that accounts are locked out after 5 wrong attempts. And also, it's corollary that you'll test that the accounts are unlocked after a certain amount of time. Abuser stories are very similar to user stories, but from the perspective of the attacker. Okay? Sometimes it's very good, useful to flesh out the attack case, the attack flow of how it would happen. Again, I don't want to get into the whole psychology of what does the attacker really want and tell me your thoughts and feelings. I don't want to be a therapist for the attackers. But I could pull this back and trace this back to my own value. As an attacker, I want to impersonate another user so I can steal their juice box. Juice box is my value. Okay? I don't care why he wants to do it, but I care how it affects my value. The value that I'm trying to provide to another user, and now you stole it. Everybody's familiar with the user story format that Agile likes to use as a I want so that So last year at the Open Security Summit in London, a group of us were talking about how to get something that simple for developers to apply to security. And we came up with this without clause. Without. As a customer, I want to buy my juice so that I can have a nice breakfast in peace and quiet. Without my credit card being stolen. Without my card being stolen. Now there's zero detail there. There's no information. But that's okay because there's no information on the rest of the user story. This gets fleshed out later during the discussion, an invitation to a conversation. That's the whole point of how the user stories work. We only get the details that we need when we need them. We don't have that information up front. But what this actually does, it gets the product owner that defined the user story to stick a flag into the user story without my card being stolen. Now, when the developer or the designer starts to talk about how to implement this user story, there is a security flag right here. And they're going to need to start talking about protecting credit card details because that's there. The rest of the details of how it's done, that will come later, together with the rest of the details of the rest of the user story. Now, this is very, very simple. It's so super lightweight. Without my card being stolen, that's the minimal threat model that you need to deal with when you deal with credit cards, right? And this is something that's very easy and simple for developers to do because it's right there. As in, I want to that without. I'm sure you're all familiar with the Maslow's hierarchy of needs. You can't deal with esteem and love and so on until your physiological needs are met, until you have enough safety to deal with higher end needs. And in the same way, we can deal with the security, right? A threat pyramid. There's no point in dealing with DOS attacks and user access bypass before you make sure there's no remote code execution or unauthorized data access. Except, of course, let's be honest, most organizations spend most of their time dealing with SQL injection and cross-site scripting, a little bit of time enforcing weak passwords. Yes, I heard what I said, enforcing weak passwords, and of course, we have to deal with spam and antivirus. But we could also turn this around and focus on our value-driven. What's the most important thing? The biggest doomsday scenario? If somebody gets access to our bank account and steals all the money, right? Obviously. And we can, before we do that, there's no point in doing the other higher level things. But once we're reasonably sure that that is done, we can now move up our business logic stack, deal with stolen credit cards, which has its own fine, leaked PII, and so on, until we get to a real business value, which relies on all the other layers. Somebody stole my juice, my market share, and so on. This is a business value driven. Now, some of you are familiar with story points. This is something that developers often use as a very rough estimate of how much work is this story will take to implement compared to that other story. It's not how much time it is, but how much work compared to that other one. For example, they usually use things like t-shirt sizes or Fibonacci. This is a small story, and that's a medium story. It's twice as much work as that other one. It doesn't say it will take you 3 hours or 2 weeks to implement. It's just twice as much work. Okay? Small, medium, large. Now, I was in artillery, so I don't really hear so well, and somebody was talking to me about story points. And I said, story points? What's that? That sounds really interesting. Tell me more about this story points. So something good things sometimes come out of, not hearing so great. And it's usually just really funny. My kids like to laugh at me about it. But sometimes good things come out of it. And it turns out this story points is a really interesting concept because it's very intuitive. And if you ask developers, out of these 10 stories, which is the worst? What's the worst thing that could happen if this story explodes in your face? What if everything goes sideways? How bad could it possibly be compared to those other stories? You don't need to put a price tag on it. Just choose which is worse out of these 2 or those 3 and rank them by how bad it could possibly be. Are we talking about a couple hours of overtime, or are we talking about refresh your resume because your career's over? Are we talking about having a little bit of a headache in the morning, or are we talking about waking up on a beach stranded behind a couple of pythons with a shark-eating dingo looking on? How bad is one scenario compared to the other? Very rough estimate, very intuitive. You can use things like dot voting. Choose which are the worst stories, and we'll threat model those. It's very intuitive, very quick, very easy to implement, very easy to get developers to do this. Now, out of all of this, there's a bunch of techniques. Out of all this, this also helps you communicate your technical attacks and threats and all that in a way that makes sense to the business. For example, how many people know how to implement a cross-site request forgery attack? Nobody, really, wow. That's old school. And executives don't even know what language you're talking. But if you tell them that I can access your account and transfer money out of your account without being authenticated, well, that's going to get some attention even at the board level. If you tell somebody, come back with a report and say, well, there's a stored cross-site scripting attack vulnerability on your application, they'll say, oh, that's wrong. That violates our policy. We need to fix that. And you'll come back 2 years later, and it's still there. But if you tell them I can take over the administrator account, that's going to get some attention. That's going to get fixed. In the same way, I can bypass authorization modules and blah, 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 blah. Well, what does it matter? Tell me how this affects me. Well, I could make sure that every juice you deliver comes to me instead of to your customers. well, you know what? They're going to care about that. That's going to matter. And in the same way, denial of service, translate that to actual business goals, actual value. You're losing revenue. You're losing market share. Nobody can come to your site and buy stuff. And when you do this, this actually really helps you even doing something like black box threat modeling. Without full access to the system design and architecture, just as a black box pen tester, you can still do a really nice threat model based on these values. What does the application care about? Why do these features exist? What are you trying to achieve? So, why is this better? Well, first of all, it's not better, it's worse, and I'm okay with that. Right? All threat models are wrong. This is a wrong threat model, but it's useful. Why is it useful? Because it's quick. You get something, get output fast. Diminishing returns, you start with the first 80% of value and the 20% of time, and you get something useful right away. And it goes with the same speed as developers because they're developers. They're the ones doing the threat modeling. They're doing it as part of their development, and threat model now becomes part of it. And it's iterative. It's part of the agile workflow. It becomes part of how they do it, and therefore it's natural for them to do it, as opposed to how we like working in the security field. Documentation is up to date because the threat model isn't separate. It is the documentation. And if you update your design, you update your user stories, you updated your threat model because it's right there. It's part of it. It helps you communicate better with other parts of the organization, with the product owners. By you talk security with product owners, they look at you like you're talking Dothraki. But it helps you to communicate with developers, with the product owners, with executives, because you're talking business value, you're talking the same language. And of course, it's a lot easier to integrate with whatever process you're using, if it's Scrum or Kanban or whatever it is, or Cowboy Agile. It's because it's part of whatever process you're using, you're just wrapping it into that. And most importantly, you don't need to be paying piles of money to jerks like me, expensive consultants or whoever it is, or NCC. You don't need us because they're doing it themselves. And it is scalable. You no longer need to rely on that one security person for 100 developers because the 100 developers are the ones doing this. So I told you what's good. Let me tell you what's bad. It is not a complete threat model by any stretch of the imagination. Okay? It is far from finding all the threats. Are we forgetting about a lot of threats? Absolutely. We're definitely forgetting a lot of things, even a lot of important things. All threat models are wrong. Some are useful. Okay? So yes, we are as wrong as we could possibly be, minimally viable threat model, and we're leaving a lot of threats on the table. But you'll come back to that later, and that's okay. Okay? We're relying on the developers to do it, and how do I know that the developers will do a good job? We don't. We need to be okay with that. That's the world we live in. How do we know the developers are doing a good job when we do the threat model? Okay? How do we know the developers are integrating? We don't. We can scan code as much as we want. Underhanded C competition shows very clearly that you could review code as much as you want and you don't really know what the developers are doing. So we're relying on the fact that developers can do a decent job. You want to give them the training. Security champions in the team will definitely help. So there's kind of a limitation that you're assuming that you'll be able to do that. And if you're trying to build this for a multi-billion-dollar international bank, really, it's probably not going to be enough. You want a more rigorous process that will give you a much higher level of assurance. But it's really cool to start with this. Get your developers to start with this. And then when you come in 3 days before they want to go live with a new version, you could start at a much higher baseline instead of starting from nothing. It's like, oh, your login system is completely bypassable. Well, okay, we actually started with a certain baseline. So if there's one thing you take away from my talk today, it should be this. Not that other one. Take this one. Shut up. I want the developers to start threat modeling. I want you to get your developers to start threat modeling. And how? It needs to be part of their development workflow by focusing on business value. Okay? Focusing on business value gives them the minimally viable threat model. All threat models are wrong, some are useful. Let's focus on the usefulness. Start with the useful part, and that's it. Don't go anywhere else unless you absolutely need it. When you need to escalate using sorry points or whatever it is, then you can do the full stride matrix or whatever it is. Thank you very much for your attention. I'll be around if you want any questions.